Okay, good afternoon all. Welcome to this joint UCCPS Hackbridge and Hackers at Cambridge event. This is our Hashcode Hub workshop, and we're very lucky to be joined with 5 past Hashcode World finalists who will introduce themselves now, saying a little bit about themselves, when they went to the Hashcode World Finals, and what they enjoy about the competition. So yeah, over to our Hashcode World finalists to introduce themselves. If you want to start, Dimitrije, I think it was, or no, Andrei rather, on the alphabetical order.
Sure. Hello, everyone. I'm Andrei. I'm now a PhD student in the computer science department. And I've been going to the Hashcode Finals in 2017. The 10 seconds version is that it's one of the most exciting competitions, just because it's firstly global, and secondly, it has super undeterministic solutions.
Hi, I'm Dimitrije. I'm also currently a PhD student in the computer lab and went to the finals in 2016 and 2017. So the first 2 years when it was open to participants from outside France. It's a fun competition. It's a competition that actually makes you work as a team more than your usual ICPC and similar, where everybody just also to work on some problems that you wouldn't see in any other types of competitions, the optimizations problems and so on.
Yeah, my name is Måns. I'm from Sweden, Lund, and I managed to go to Hashcode Finals in 2019, and I've participated since 2016 and also organized a hub in Lund since then. And I think the contest has like a really fun format, and it's like a great opportunity to learn more. I would say like this is definitely the contest where I've learned the most computer science from compared to other contests.
Hey everyone, my name is Petar. You will hear a little bit more about me in the slide deck that will follow right after this, but I'm a former undergrad and PhD student at Cambridge, and now I'm a senior research scientist at DeepMind. I have competed at Hashcode for several years, and I was in the finals alongside Dimitrije in 2017 when our team won 5th place. So as echoed by what others have said already, Hashcode is pretty much by far the most fun competitive programming event that I do. And yeah, it's just really exciting, and I hope to share some of the spirit of the event with you today. I think we still have Zoli.
Yes, thanks. Hi, I'm Zoli. I'm a 3rd-year computer science student here at Cambridge, and I've been to the World Finals of Hashcode in 2019, which was actually the last one, which was held on site. So yeah, also it's quite recent. And also I agree to others that basically what I really enjoy in Hashcode that it's like so freestyle, and also that it's like a team competition where it actually matters to work together and parallelize things, maybe the workloads, and also with like a live scoreboard is pretty fun to actually watch your scores for each submission like in seconds. Yeah, and I think that's it from me.
Yeah, thanks so much all. So just a little on the format of this event. So we're going to be doing a panel discussion, and then for the first half of the event, and then for the second half, Måns is going to talk us through his template for approaching Hashcode problems, and hopefully that will allow us to kind of like interactively work with some kind of Hashcode problems. And so, yeah, to kick off the panel discussion, and anyone is welcome to put questions in the chat at any time to forward on to our world finalists. I'd like to, it seems right to have Petar introducing us to what Google Hashcode is as an affiliated Google employee. So yeah, over to you, Petar.
Great. Thanks, Arthur. I will just do a very quick introduction about myself and about Hashcode to kickstart the entire panel. I'm sure we'll get to much more interesting parts about participating in Hashcode like once the panel gets kicked off. But yeah, so once again, hey everyone, my name is Petar Veličković, and I completed the undergrad at Cambridge in 2015 in computer science. I also finished my PhD here in machine learning in 2019. and I'm now employed as a senior research scientist at DeepMind, which is part of Alphabet. So I am not allowed to participate at Hashcode anymore, but I do have some history with competitive programming. I've participated at the regular ACM competitions. I've also participated in these hackathons, particularly Hack Cambridge, and I won a few medals in both of those events. But Hashcode is a contest where I've competed for a few times in the qualifiers, and in 2017, alongside Dimitrije and two others, we've been able to progress to the finals, where we actually ranked 5th overall. So it was a very, very exciting event and like a very exciting time. And now I've actually joined the Hashcode development team. So I am actually part of the team that has developed the problem that you will be faced with in less than a week from now. So what is Hashcode? If you've never seen anything about Hashcode before, it can be summarized as, at least out of all the competitive programming events I've been to, by far one that was the most fun. Here you can see a video. Well, that was a promo video in 2018 showing the finals from the year before, and that's myself, Dimitrije, and like another one of our team members in the background there. So this is what the World Finals look like. Teams of several people, usually 3 or 4, team up to solve marathon-style tasks. And what this means is that you're given a programming task that is based on a real-world engineering problem that's relevant to Google. So things like optimizing data center consumption, optimizing Google Books usage, drone deliveries, and whatnot. And typically, unlike most competitive programming events that you might encounter, the problems are usually intractable to solve. That is, it is not expected that there exists a solution that will solve every possible input optimally. If you're interested in tractable puzzles that are super hard, I would invite you to check out Code Jam, which is another Google-sponsored competition, but where there usually exists a correct solution that everybody needs to implement. And what the aim is, since the problem is intractable, is to basically try to get the most optimal outcomes possible with approximate solutions, like heuristics, that they won't solve the problem perfectly, but they'll get you most of the way there. And everybody is scored based on the performance on some sample inputs, and about the top 50 teams advance to the final round. And one thing that's very important to stress is that you will be given the inputs to the problem, and it's up to you, like completely up to you during the 4 hours of the competition, how do you produce outputs. You can either decide to solve some examples manually. Some of them usually will be solvable manually. You can use any of the standard programming language environments like C++ or Python, or you can even use your own favorite data visualizer, or maybe even like off-the-shelf combinatorial solvers to get a feel for what the optimal solution might look like. The only thing that's disallowed is to collude with other teams or like cooperate between teams. But otherwise, anything that you can find and use as a programming environment to solve these optimization tasks, you can use. And I will just briefly show you, if you've never seen a hashcode problem before, what a hashcode problem looks like. So it's usually given in some kind of abstract form. Here it's the practice problem from this year, where you need to choose which pizzas to deliver to hashcode teams, and to give them as diverse ingredients as possible and try to deliver them to each team. So, and this is the kind of inputs that you might receive on the first table here. You have a very clear description of a particular data set. So you know that there are 5 pizzas that you have. There's 1 team of 2, 2 teams of 3, 1 team of 4, and then for all of the pizzas, you have which ingredients are on those pizzas, and then you need to produce an output file which specifies how the pizzas are to be delivered across the various teams in order to optimize a certain score metric. So yeah, that was just a very quick introduction to what a hashcode problem might look like. I think that now is a good time to get the panel started. So thank you for listening. And of course, if you have any questions, feel free to post them in the chat as we talk along.
Yeah, thanks so much, Petar. Yeah, so to kick off the panel discussion, if any of the panelists want to jump in to answer, so the clock turns, I think it's 5:30 this year. You open up the hashcode problem. You have 4 hours to solve it with your team of 3. So how do you guys approach a hashcode problem? The most general question we can ask.
Yep. I think I can break the ice over this one, and I'm curious to see how others did it. But in my experience, almost all the, call it winners, or all the top teams use the same class of solutions, meaning all the winning people either use like dynamic programming, or they use binary search trees, or they use the same class of solutions. So in my case, I suggest that it's worth taking time of thinking carefully what's that class of solution that is going to be winning ones, because I don't believe that there is much time for trying multiple solutions, like different type of solutions. So my first suggestion is take 30 to 60 minutes of the first time and like genuinely think what would be the actual type of solution that you can further improve, but not change so much. Is it similar with what other people approach Hashcode?
So I guess I'll just quickly jump in and say that, like, to an extent, there is usually a very clear sort of direction that puts you at the very starting point of like getting enough points to be up there with everybody else. But one thing that is very important is that once you get up to the range of like the teams that are close to advancing, and there's usually a lot of teams that are close to advancing, the difference has actually become quite minuscule. Like it's, well, I'll say tens of thousands of points, but usually tens of thousands of points is actually not that much when you add it up over all of the different tasks. Because often you'll get like, I don't know, 1,000-point bonus for making the solution slightly improved or something like this. And actually, the different data sets, at least from my experience as a competitor, have been designed such that they will try to break different kinds of solutions. And you're only rewarded by how well you perform on the sample inputs. So if you see an input that's perfectly solvable, you should perfectly solve it. Like there's no reason to apply a heuristic on inputs like that. Then if you see a solution that has certain statistics, like you should obviously try to either visualize your data or try to see what the distribution of the inputs is like. If you see that the distribution is designed to like deliberately enforce a certain solution over others, then maybe that would be actually a good chance to have someone in a different solution. Obviously, this is something you should kind of spread the workload across your team members, but usually the different inputs will admit slightly different solutions, and therefore I guess I'm a little bit contrarian to the opinion that Andrei had, in that like maybe there is value, especially once you get to the higher ends of the points range, that there should be actually multiple heuristics implemented and like separately tried on the various inputs. But yeah, I'd love to hear what Dimitrije thinks about this, given that we were in the same team.
Yeah, I agree with that. The first thing I would do in any hashcode competition is just open the input files and take a look at them, because if all you do is read the problem statement and start thinking about what your solution might be, all the constraints that are given in the problem statement are quite misleading, in that they're going to say that I don't know, anything in the input can be very long. You can have for example, in the problem Petar showed, you could have a ton of pizza, you could have a ton of teams, every pizza could be huge, and so on and so on. But when you actually look at the inputs, a few of them are going to be special cases that you can solve perfectly. And then in the others, well, they're not going to be the biggest possible inputs that satisfies the constraints. And also, again, some of them might have some special properties that make a certain heuristic work better. So just taking a look at what the test data actually is can inform your solution. And for that, I mean, you can just open the file, take a look at it, compute some simple statistics on it. But also, in most hashcode competitions, if you upload an empty solution, you're going to get a nice visualization of the input.
Yes, I will add to that we try every year, and this year we've tried really hard to give a really nice visualization of the input. So actually submitting an M solution is a good way to start, just to get a feel for, like, we help you a little bit by showing you what the data looks like. So generally, it's a good idea to get off the ground quickly and try to just submit something so that you know how to read the input and plot the output, and also see what the inputs look like, because I think that's going to help a lot in figure out what kinds of things we might be hunting for in the example inputs.
So I would like to add to that a bit, and you will see during my demo kind of like how I work these problems, and I try to get something up and running that gets like at least like explores the score of each input files a bit quite fast. So I try to do like a very simple solution that is trying to like, this is not the final solution, just to get something, to get some idea of which input files gives a lot of points. And like combined with that, I try to like, or my team tries to like estimate the maximal amount of points you can get on each input file to like make sure like where are the points left to get, because as you all said, like or as you said, Peter, I think it's like really tight in the top like when advancing. So like you really need to find which of the input files there are points left to catch.
I also wanted to add, so basically, yeah, our team also like usually starts with just to get some feel about the data or what we are dealing with, because it's very important. Like you can't just like start thinking about some general solution, because like these test cases are very specific for which you have to solve the problems. And also I also share this view what Måns said before me, that it's very important to identify which test cases are like the most important ones in some sense. Like there might be some test case where what you will see is that basically all the teams probably do, let's say, some kind of greedy approach, and it's kind of the same thing, and you won't have like a huge difference in the scores. Whereas maybe at some other test cases, you can have like a large variety of ideas maybe, and even some of them can be solved exactly, and it's very important to identify those. And also, I think it's fairly important to like compare to some ICPC style of competition or like this usual competitive programming style of competitions, that I think here it actually matters to sometimes write code that can be reused, to like to make things a little nicer, because that will like certainly help you. And also like you can, our team usually also does something like which I'm sure like many teams also do, but there's an importance with this kind of thing, that you can also like write things like, for example, I also think Måns will show something similar in his demo. But for example, to write some function maybe, or some method which like improves some solution. So let's say you have some solution already, and you basically this can be parallelized. Like one team member can just start writing maybe some methods which is like, given a solution, let's try to somehow improve it a little, and then it doesn't even matter like what's the actual solution, how it was generated with some other method maybe, but this way, like I think a lot depends on teamwork as well. Yeah.
And I would also like to add that like my team always implements the score ourselves, so we can score the solutions locally. Because like interacting with the web interface, it takes like at least 1 minute to do a submission. So it's like really nice to just like get the feedback directly that, okay, this ID was good or was not good.
Yeah, I would say that implementing, like basically you have multiple members on the team. Some of them can implement input processing, some can implement some possible initial solutions, and at least one team member should just focus on implementing a function that, taking a solution that you have, tries to score it. This is very helpful, not only to like get a good local sense and quickly check many different possible strategies, but also once you get to the point of, okay, we've implemented sort of everything simple that we can think of, and now there's 2 hours left or 1 hour left, and we don't know what else to do, but there's still some points to be gotten. usually one strategy that at least we found can be magically powerful is the so-called gradient ascent or hill climbing method. I think maybe Dimitrije should say a bit about it after I say this, but basically it involves tiny changes to the solution that your heuristic has built, and then use your scorer to remember which changes brought a better score, and then just keep improving that way. And this, like when we went to the World Finals in 2017, when the scoreboard froze 1 hour before the end of the contest, we were almost at like the bottom of the list. We were 48th out of 50 teams. At the end of that hour, just by doing this simple hill climbing technique, we got up to 5th place from all of the teams. So basically that's how close it can get. And that's how much benefit you can get just from randomly changing some semi-optimized solution and then using the scorer to help you save solutions along the way. So yeah, Dimitrije, do you want to elaborate a bit more on this?
I think Petar described the basic idea. So once you already have a solution that makes some sense, that your greedy algorithm or dynamic programming algorithm or whatever else you have found, you can often improve it by just doing some simple changes, like making a small random change in your solution and seeing if that improves it. And if it does, then you keep the change. If not, you revert back to the previous one. And then just doing that iteratively. And what we would usually do is have that implemented, and then once improvements where we only make small changes get you stuck into a local optimum. So once that stops improving your solution after, I don't know, a few hundreds, a few thousands of tries, then you try making a larger change, accepting that this could potentially make your solution worse, and then use the small changes to see if that led to escape the local optimum. And if not, then reverting all the way back. And for all of this, it's very important to have your own scoring function implemented, and usually also to have it optimized in such a way that if you already have a score computed on an input, you can easily compute the score on an input that was changed slightly without having to process the entire thing. Because otherwise, you just won't have the performance to try enough changes.
I would like to add a bit on that too. That's like, so the kind of changes, I guess, that you were talking about, but I can give an example. Like, so maybe like you have, so like maybe you have like two parameters that you're like sorting on. You may be sorting on like the one divided by the other or something, because that's like the score you get divided by like how close you are or something like that. If you just like try to, one thing you could try is basically to change, like to take the power of 2 of the thing that you have on top and then just divide, or like do these kinds of small changes to your sorting order. And you could even like try to do some kind of where you don't know how to distinguish, you could try to add some randomization as well to like see if you see if that helps. And I mean, usually this for this to help, you need to have something that is very close to, I mean, you need to have a good solution when you start doing this. If you start doing this with a solution that's like skips an entire part of the problem, then it's not worth trying to do randomization on that, because it will only give you like a couple, like, I mean, some % more points.
Another thing is we told them that the differences are tiny, but to give an actual numbers, the differences between like the top 50 is like on a 100 scale, the top one has 100 points and the 50th has like 98 points. So the difference is like 1 to 2%, which is super tiny. This is why this random changes actually work, because it's more or less how well you fit on the examples. And I think it's super important to think about what you do in the last hour, because in the last hour, the scoreboard is frozen. So you are not going to see what others are doing. And usually, as Petar said, the main difference is made in the last hour, because everybody has their solutions, everybody has their scorer, and everybody has their, random search. So everybody just gonna tune. And one general, so the punchline is just stay in the last hour, because that's when you either win or you lose. But typically what's common is the scoreboard is frozen and you are on the position of 36 out of 50, or you are, let's say in the qualification round, you are 250, but your point is like 96 and the winning is 98, so it's super tiny. And I think people get usually into making predictions, like I'm going to win or I'm going to lose, or like what's going to happen. And that's just nonsense, because your job there is not to be right in predicting whether you are going to win or not. Your job is actually, like, you are not rewarding by predicting if you win or not. And I think this is a good incentive of just not thinking whether you are winning or not. Simple rule of thumb, you can even not open the scoreboard in the last hour if you don't want, but don't try to predict whether you lose or win, because it's just pointless. But stay there until the last minute to get all the points.
I think that's a good like psychological advice, and I would actually add there's a flip side argument to that. If you're starting out and like at the beginning you're not like able to implement a solution very quickly, or not getting the results you want maybe within the first hour or so, I've seen many teams just give up at this point, and there's actually not a lot of point in doing that, because as I said, the difference, and as Andrei verified, like the differences are so small that like if you break out and make an interesting heuristic ready in like, at the end of the second hour, at the end of the third hour, and that immediately shoots you up from like, 10,000th place to like 100th place. Like that's how quickly changes can happen, because remember, there's a lot of points accumulated over all the test cases. And like, I guess one key part is, like no matter how slow it might be going, like it's good to get like just a quick and dirty solution out there, and then just take as much time as you need to have a good and robust scorer, and like way to manipulate those inputs, and just like don't give up if you see yourself fall to like 20,000th place. It just means you haven't submitted anything over that time, and that's okay. Like you will catch up the moment you actually have something done and implemented. So the trick is basically just not to look at the scoreboard until you absolutely need to, like to get a feel where everybody else is, to know what kinds of points you should be picking up. And actually on that line, I think I'd like to ask a question to everybody on the panel, which is like, obviously we're saying this from perspective of people who did this contest before, went to the finals, and like probably many of the people listening to us are like also have some experience competitive programming. But what would you say to someone who has never done Hashcode before? Like how would you advise them to approach it?
I can actually start with something for this question, because I think the first time I was participating in Hashcode was actually just like a few years ago, really, like I don't know, like maybe 4 years ago or something. And before that, I've already like done a bunch of like competitive programming, this other kind of like ICPC style of things, IOI, maybe code forces, this kind of stuff. So this thing is this thing was like completely new for me, and also for my teammates from that time. And I think the mistake we like made was that when we were trying to think about solutions too much, and we haven't actually like started implementing anything in like the first, I don't know, 1 or 2 hours. Like we were just like brainstorming like what to do. And I think this is pretty much not the way to go when you do Hashcode, like as we realized, I don't know, after the contest basically, because it's really like you don't need like some extraordinary idea most of the time. Like we were thinking that, oh, like this greedy approach which we came up with is like too simple. We don't have any chance of getting any scores with that. But this is actually not the case for Hashcode. You can actually get like a really like huge amount of points just with a very simple idea, and that's also what other teams are also doing. Well, of course, then if you want to get to like the top places, you obviously need some extra with all these maybe parameter tuning and all these tricks which the others mentioned already. But I would just suggest to like keep it very simple, because I don't know, that was like a mistake I made when I first participated in this competition, that we're trying to come up with something something big, but this is actually not the way to go, I would say.
I can add to that as well. So like, so the first time I was in Hashcode, it was 2016, and it was quite a complicated qualifying problem where you had to like schedule drones to like pick up stuff and deliver it to different, like, and there were warehouses which had different stock, and you had to like fly around the drone and deliver stuff. So it was like, I think, like quite complicated and quite many like dimensions to think about, and like we really never, we hadn't prepared at all for that competition. So like we managed to get some points, but not like I mean, way below like the threshold for advancing to the finals, etc. And I think like a good way like is to just try to skip one of the dimensions in some sense, like basically try to do it with only one drone to start with, or maybe try to like, yeah, I don't know, just take the orders that you're gonna deliver in order instead of trying to like find the direction first. So you have something to start out with, and then after that you try to continue improving your solution.
That's a very good point, and I'll actually, before like letting the others answer, I just want to follow up on that point specifically. I once participated in a marathon contest, which wasn't Hashcode, but it's very similar in that we needed to optimize things. And the TLDR is we had to build a subway system for my hometown, and they gave us two pieces of input. There was this huge XML file which told you the geographic coordinates of every single interesting point in the town, and how they're related, what the distances between them are, and so on and so forth. And then you had to solve for many individual test cases where they told you just this many people want to travel from here to here, build an optimal subway line with the budget that you have. And it turns out that you can get basically 95% of the points by just completely ignoring that complicated XML file and just building where there's the most people in the individual test cases. So basically, to kind of summarize, you can usually get really good solutions by ignoring a huge chunk of your input and then gradually incorporating it backwards once you want to make a bit more sophisticated solution. I saw there's a question for me, but should we first, I don't know, Dimitrije and Andrei, do you have some advice for new starters that you'd like to share?
One thing that I want to mention is we've all been talking about algorithms and how you approach solving a problem so far, but another big thing in Hashcode that you don't have to do in other competitions, but is very important here, is just being able to work as a team and to work on one implementation of a solution with all members of your team at once. Like, for example, if you're in an ICPC contest, you only have one computer and there's one person sitting in front of it and typing, and everybody else is just advising them or thinking. And here that's not the case. Here you should really be making sure that there's multiple people coding at once, which means that you're going to need a way to manage multiple people working on your solution at once. And doing things like, I don't know, uploading functions to Pastebin and sending links to everybody else is not a good way to go. And making sure that everybody has Git configured or some other version control system that you prefer and knows the basics of using it is very, very, very useful. Not that we managed to get everybody to use Git successfully every time.
Yes, I would also add as a wrapper that there is value in participating even if you don't expect to win from the beginning. And I have a super, I think, hilarious experience on this. So I qualified to the World Finals in 2017, but the reason I went to the actual participation, I had a team and we were talking, hey, shall we go to Hashcode? And I was like, fine, let's go to Hashcode, because I remember that last year I was like 150th. But I was wrong. I was like 1,500th, but for whatever reason, I remember that I was close to the actual line. So I said, okay, let's actually try it. but then 2 hours before the actual hash code, I dropped. I said, yeah, but there is no point in participating because we are not gonna go further because, you know, it's bigger, it's hard, or smart, it's. But then again, so this was 2 hours before the competition. I said, I'm not gonna go. And then 1 hour before the competition, I said, okay, let's just go and see what happens. Funnily enough, we got to the world finals, but the point is there is value in participating, even if you don't, let's say on paper, expect to win, because you just don't know what's going to happen. Like the moral is I participated just because I wrongly remember that I was close to the finish line last year, but I wasn't. And there is value in participating because the nature of the contest is such that there is some randomness, which can be positive to you.
Yeah, I would definitely agree with that. Like there's value in just learning the ropes and working as a team and just building something together. And the actual final position doesn't necessarily matter that much, in my opinion. Like going to the finals is surely super exciting, but I've had a lot of fun even in the years when we failed to qualify. Like I think it's very valuable either way, and it was always good. Like in team spirit, even when we didn't have all of our team members in the same place, so some of them were virtual, it was still like a very good team building exercise. And I want to answer the question that Hugo asked in the chat. So when we're designing the problems, do we usually have a specific solution in mind for each test case that we expect to be the winning one? Do we intend all the parameters to be useful? Okay, so having taken part in actually designing a hashcode problem, I can say that most of the things that we would expect are probably true. So, but I would actually flip this. We don't design test cases with a winning solution in mind. We actually usually design test cases with a solution we want to knock out in mind. So basically, we know that some people might try a heuristic of some sort, and we want to make sure that if that heuristic is simple, that it doesn't take all the points immediately. So we're going to try to design test cases that will be specifically tricky for certain classes of heuristics that we know. And then there will be some test cases where we don't really have a name like that. And if you've participated at Hashcode in previous years, you will know that there's always a few test cases that are inspired by the real world. So I remember like in 2017 in the finals, we had the task of placing routers in buildings, and they gave us the exact map layout of the Paris Opera and the Google Paris office to like place routers in them. So you can always expect some data sets to just be real world. Some data sets will be maybe purely randomized. There will always be a data set that's easy enough to be solved by hand, usually, so that, you know, even people who haven't had that much experience programming can try to solve an example. And for all the other ones, yeah, the key is more to think about what are the easy things people might try and try to discourage that from winning everything. So basically make sure that you need to put a little bit of effort or implement a few different strategies in order to really advance in the scoreboard. And yes, I would say that like maybe not across all the examples. Some examples will favor some parameters more than others. So in some test cases, you can just ignore some of the parameters. But taken over the set of all test cases that we're going to give, it is important usually to look at every single input parameter that we give you. So yeah, Hugo, does that answer your question?
Yes.
Yeah. All right. Perfect.
Right. Thank you so much to the panel for everything you've discussed so far. I think this is probably at about the right time to actually get looking at some hashcode problems. So now I'll hand over without further ado to Måns.
All right, thanks. Let me just share my screen here. Oops. All right, so I will be doing a demo here for Hashcode, solving the problem that Peter presented before about the pizza assignment to teams. So, and I will be using a template that I have written. I've developed it since 2018 and like improved it on each Hashcode instance I've been a part of. And like the basic idea is that like it's very, very annoying to keep track of all your output files each time you run your new code that you have just written, and you get some output, and like you will like overwrite the output that you got before, and yeah, like so I found this to be a mess when I completed the first times. So that's why I wrote this template to like help me keep track of the output files, and also keeping track of like the best output files I've produced so far. So there is a link here. I will post them soon, and it's written in pure Python 3 and with no dependencies. We can go into that later, but yeah, so I will be coding in Python 3 today. And I have like, I want to show you some images to like set the tone. So basically I have something I call like a solver, which like takes an input file and produces an answer file or an output file. And then I have something called a scorer, which takes both the input file and the output file, because usually you need the input file to score the output file. So you take both, and then it produces an amount of points. And the template helps out like running these. So you just have to write these, and we're good to go. So like this is like the main structure of the template. So main.py is the entry point. And you give it an input file, a solver, and a scorer. And then it will run the input file through the solver, and then the output file produced through the scorer. And it will produce a folder inside, yeah, and you will see this later, but it will produce a folder where it saves the ans file. And if it sets a new record, it will put this file in a submission folder. So inside the submission folder, you will always have the best answer files for each input file produced so far. Yeah. All right, and my plan for the demo is like first show you where. So I've made a fork of my template on GitHub, and I will be pushing to it while I code. So you can like follow it there, and then you can pick up that code afterwards and continue to improve the solution if you wish to practice. So I will show where that is and give you the link, etc. And then I will download the input files from the judge system. And then I will start out by writing a parser for the input. After that, I will write the scorer. And then I will test the scorer with the example test case. After that, I will write a simple solver, and then I will improve that solver a little bit. And you will be able to follow along, and like please interrupt me with questions if I'm like not explaining anything, like if there is something you don't understand. Like also I will try to pause after each of these steps, and you can ask like for a chance for you to not interrupt when you ask a question. All right. So I will, yeah, let's see. I will give you this. Whoops. No. How do I write in the chat from here? That was difficult. Here is the chat. All right. So basically, here is my template, and I have just copied the template. Yuck. I've just copied the template to this repository on GitHub. And I have it checked out. Getting all these weird pop-ups that are in the way. All right, and I have this checked out in my editor here. All right, so let's just start by downloading the input files. So this is the judge system, and like in the real competition, you will there will be the qualification round here instead. And I will download the PDF as well and push that too. All right, and I save the input files in a folder in. You will see that in a minute. Right. So this you only have to do once. All right, and here you can see the input files, and also I noticed here that so inside in there, so the A example in this practice contest, it does not end with in, and my template assumes that, so I will just fix that. Yeah, like that. All right, so inside in now every input file ends with .in. So like, and it's a good idea to do this, that somebody does this and commits that to your, like if you use Git or a versioning system, like that one of your team members does this and commits it so everybody has it and doesn't have to download it themselves. All right, so I will be a good teammate and push the input files. And don't spend too much time writing fancy commit messages. All right. All right, so let's get started. So I write my data parsing in a file data parser. Let's see, let me get let's see if I can. Yeah, all right. Okay, that's okay. All right, and like so you already seen a bit of this description, and like so the one who does the input parsing, which is usually me in my team, I usually just like skip all of this. I don't read it. I just go directly to the input data set. Maybe I skim through a bit of it, but or maybe there is something in the input description that like is not clear to me, and then I will have to go up and read through. But a lot of the time, like the description is very, very long, and it's better to just get started. Usually, it's like clear from the input description what you get in your input file. And in the template, there is like this function parse, which both solvers and the scorer uses. So, and here the point is to like, I get the input file as a string, and I will fill this. This is a Python thing called a namespace where you can just put variables. So I will fill that namespace with like the parsed input. And I have some helper functions up here, NL and NLI. So the first line of the input contains 4 integers, M, T2, T3, and T4. So I can just fill the namespace with these. All right, and NL will parse integers from the next line, split them up and parse them as integers. All right, and then there comes some pizzas, M pizzas. All right, so however here I get ingredients, so I don't get integers. So I can also just get the next line by doing next on an iterator in Python and split it up. And the number, yeah, let's see. So the first integer is the number of ingredients. Okay, so I don't really care about that, but but the ingredients are the things that comes after. And I can extract that in Python by doing 1 colon. All right, so and usually I will create some kind of dictionary object with the information that I might need. So yeah, and usually I like remember the ID as well of it, so I can pass it around and still remember the ID. All right. Let's spell it out actually. All right. And then I will add it to the list of pizzas. And then I will have to add it to the namespace as well. All right. So this this input format was, I mean, it was quite simple, so it didn't need much code to parse. But it's very nice to get it structured. All right, so I can actually let's see. Can I maybe full screen this? Oh, to move all the heads. Okay, and I can run the parser. If I just run the parser, there is some code here that finds all the input files and runs the parser on all input files. So before I push it, I just make sure that it doesn't crash. And it didn't. And it created inside the in folder. It now created a .json file for each input file. All right, so I will now add that. Add the data parser and the JSON files with them. All right. Are there any questions so far? I'm now, let's see. Oh, all right. I'm now done with the parser. Now I'm supposed to write a score of this problem. Let's see.
There is a question.
Yep.
It was from Ewan asking, what's the terminal autocomplete feature?
It's a terminal called fish. Like the shell is called fish. It stands for friendly interactive shell. So it like yeah, and it auto completes for you. Yeah, basically. I can send a link to that as well later. All right, let's go ahead and do score. Yuck. So I have all these images. Let's see. Yeah, I can just make it one. Okay. All right. So let's go ahead and score. Call solution. All right. So here we have a score file. It takes the input and the output. Yeah, it already calls parse here, so it gets the namespace for the input. And like usually I will try to when I write the score, I will try to like write asserts that makes this like that crashes the score if the input file is not like correctly formatted. All right, so first comes like the answer file format. First there comes an integer d. So I can get that by nextint or ni. And now I will assert that 1 is less or equal to d, less or equal to ns.m. No, wait, sorry. It should be less or equal to the sum of t2, t3, and t4. And that I have here, ns.t2, ns.t3, ns.t4. All right. And now there are D team descriptions. All right. And here I will just get a list of integers. So let's see. And so in the validation, there are some, like in the validation section, there are some like restrictions on the solution. So for example, each pizza must be part of at most one order. So I will just have a set, which are like the used pizzas. All right, and the first, like I'm only allowed to do 2-person, 3-person, or 4-person teams. So I will just take NO is L of 0. That's the number of team members. So I will assert that 2 is less or equal to NO less or equal to 4. All right, and I will also have to make sure that there are not like the answer file does not like specify too many 2-person teams and 3-person teams and 4-person teams. So let's just have C2, C3, and C4 variables that all start at 0. All right, and yeah, actually, all right. So yeah, I will just do like this. If NO is 2, then I increase C2 by 1. If NO is 3, I increase C3 by 1. And if NO is 4, I increase C4 by 1. All right. And then I will have a look at the pizzas. So the pizzas are the remainder of L, and there should be exactly NO amounts of pizzas. So I will check that as well. All right, and then I will walk through the pizzas. Let's see here. So for pizza ID in pizzas, I can, yeah, or well, yeah, assert. Should be between 0 and ns.m, and it is not allowed to be used already. Not in used, and then I will add it to used. All right. And then I would like to get the ingredients combined on each pizza. So like the points you get are like based on the number of unique ingredients on each pizza, but I will just have a list to start with. All right, so I can find the pizza like this. All right. Sorry, I'm coming back in like 20 seconds. All right, I'm back. I had to tell my girlfriend to be a bit quiet in her Zoom call. All right, so I can extend this all ingredients list with the ingredients on the pizza object, and I call that key ingredients like this. All right. And then maybe I should have a total score equal to 0. And so if you look here, how much score do I get? Well, actually, I get, for each delivery, the delivery score is the square of total number of different ingredients on all the pizzas in the delivery. So to get the number of ingredients, I will just take the length of the set of all ingredients. So then I will just add to the total score, I will just add squared. All right, and then I will add, then I will just return total score. All right. All right, I think this score is basically done, but like it's very easy to make. No, actually, I forgot one thing, and that is to check that to check these variables. So I will just assert C2 is less than or equal to ns.t2, and then I will do the same for C3 and C4. All right. Great. So, but it's very easy to have errors and like it crashes, etc. So what I usually do now is that I create an example solver. So I just copy my my regular solver or my like template solver to something called solve example. All right, and yeah, here we go. So and this will just return this example example solution. So let's say there were 2 orders, and unfortunately these ones, they are like copyable, but you don't get the correct like correct white spaces. So I usually just retype them instead. All right. And this is a multi-line string in Python, so it will basically, yeah, like you will get the new lines inside the string. So now I can write. Now I can run the entire thing with main, and I have to like make sure that I'm using this solver. So I have. All right. So I have to move this around. Okay. Let's see. So if I run main.py-h, I get some like helping, like what kind of arguments I can give to it. And there is an example down here, which I typically use. All right. So I will have solve example. Oh wait, solvers/solve example. All right, and then I will run it on in the example file. All right, and yep, I had an error in my scorer. So let's see, what is the error? All ingredient.extend. Yeah, I have a typo. Yeah, well, yeah, there was a typo up here. Oh, never mind. All right, let's see. All right, and now the score is 65, and that was the best so far. So let's see, and they also say that I should get the score 65 for this example. So like proof by example, now my scorer is correct. Any more questions so far? Or wait, maybe I can look at the chat.
The question is, how important is getting access to better CPU power through, for example, Google Colab?
Like I have never used, like I have used a laptop like every time I've been on Hashcode, and I think like, so I mean, to some extent, sometimes you might want to do a solution that is like quadratic and n is 100,000, so like you don't really have like, and then it can be fine to just put your computer running for like 10 minutes or something. But usually you want to like print something to like see how it progresses, to like estimate when it will be done if you do these kinds of things. But like not that important. One thing I typically do is like, if I have something that is too slow, I try to be able to parameterize, like instead of doing it quadratic, I just like maybe look at 100 random elements and try these instead of like the entire thing. And then I can like specify how many I should use to like have a somewhat faster way of doing my solution. Yeah. All right. I will continue here in the meantime. So now I would like to try to create my first real solver. And I will copy the solver and call it like solve simple. So like to just get the score, I will just assign pizzas to teams. Like I will not do anything fancy, like base it based on like what ingredients this team has already received, etc. I will just take the pizzas and assign them to teams. So and I will write a small function to just like let's start by getting by having like which pizzas are left. Yeah, and just insert the IDs here. All right, so these are the pizzas I have left. And then I will write a function that can pick some pizzas for a team. So the team NO is like the number of persons in the team. So I will just like check if there are enough. If there are not enough pizzas left, I will just return none. Otherwise, I will get the list and I will take out some pizzas here. So I will do left pizzas pop. So pop takes like the last element of the list and removes it from the list in Python. And then I will add it to L. And I will return L. All right. And then I will basically just create, like pick these out for teams. So yeah, let's just start by going through the two-person teams. And I will just pick two if pizzas are not none, I will add it. And then I will like do the same thing for 3 and 4-person teams. All right, and then I will have to like create output from this. So I can just first append the number of teams. And this will like be a list of strings, and then I will join it together. Yeah. So now I need a string that is, or wait, actually I can create a list that is like the length of the team plus the team. That is like the output format they want. And then I can join that together. This is on Python Magic, but basically just putting integers space separated on the line. All right, and then I will append that to out, and then I will return \n.join out. All right. So let's see if we take. Oh wait, sorry. So now we take the solve simple, and let's just run it on them consecutively. All right, I got 65 on A, on B, 7K, on C, 200 million. So like when you do it like this, you get really a good feeling. Like C is worth like super much compared to B, at least with this solution. Maybe there are more points to receive on B, but like C has definitely the most points. And D, I get 1 million, and E, I get 4 millions. All right. And now it has created this submission folder with the ANS files. And so let's try to do, or yeah, are there any questions?
There has been one from Lars asking if your team wants to write solutions in languages other than Python, is that possible with your template?
Yeah, so it is possible, but I can go into that a bit further down the line. But yeah, we can come back to that. But there are some possibilities to do that. All right, so let's summation. And actually, yeah, I have already solved this, but so you can see my old submissions, but we will pretend that this is the first time. So actually, you need to provide the source code as well in a zip file. And I have a small script for that as well, called package.sh, and basically it will just include every Python file in the top directory and every Python file in the solvers directory. So if I run this, now in the submission folder, there is src.zip. All right. And so one point on that is that if you use other languages, make sure to like edit the package.sh to also include that. So you actually submit your code. All right. Oh, full screen difficult. Don't know why I always get full screen here, but oh wait, invalid OAuth token. Refresh. All right. Yeah, and as you can see, it takes a bit of time to do these submissions. So it's like very nice to just get the score yourself. But I mean, you really should do like a submission early on to test your score to make sure that there are no errors in it. So one thing you can do before the scoreboard freezes is that you basically just start holding your submissions, and then you submit it directly after it freezes to not reveal how much score you have received yet. All right, let's see. Oh, oops. So I think I submitted from the wrong folder actually. So see, I have already solved this before. So I will submit from the correct folder. So I have it over here. All right. Yuck. Let me just check that I am, yeah. All right, it looks quite similar to what I got, but let's check. So I have a file as well called SumScore, and this one is not made for like having such a large editor, but or zoomed in editor that I'm using right now. But as you can see, so let's try to compare here. Yeah, so I got 65 on A, the same, 7,428, and here 213 million something, 500 seems correct, 1 million something, 4 million something. All right, great. So my score seems to be correct. Now I can take some questions again if there are any more in the chat. All right. All right. So I will continue and I will try to improve this solution a bit. And like typically I try to like when I have a solver that is kind of like beats a record and I want to like change it in a change it quite a lot. I just copy that solution and like start in a new file so I don't get any merge conflicts. You don't want to get merge conflicts during oh wait, actually, you know what? I forgot to push my score and forgot to push everything. Yeah, now my teammates would have been very angry with me because I haven't given them the score. Okay. Add scorer. Add. All right. All right, so now I will copy the solver again. And now I will try to do some sorting, I think. So let's name it that. All right, so right now we're just like picking the pizzas arbitrarily, like based on, or not arbitrarily, but based on the orders you receive them from the input. So now I will, so one observation from the problem is that you get like quadratic score, like the score is the square of the number of unique ingredients. So it seems like if you have pizzas with a lot of different sizes, it seems like a good idea to give like all the large pizzas to one team and then the next large to the next team. So you get like a really huge score for one of the teams. Instead of like giving small scores, like a mean score to every team. So I will basically just sort these pizzas. That will be the only thing I do. So sort key, and in Python you can